Welcome to Homework Lib.
So the maximum voltage across the capacitor is given by V max, which is equal to Q over the capacitance, where Q is given as 6 times 10 to the power negative 6 coulomb, and we divide that by the capacitance, which is 250 times 10 to the power negative 6 farad. So that's 0.024 volt or 24 millivolts. For part B, you know that initially the current flowing through the circuit is 0, so the total energy in the circuit is basically the energy stored in the capacitor, which is Q squared by 2C. Now when the maximum current flows through the circuit, we must have UC equal to 0 and UL equal to Li max squared by 2. Because when the current flows through the circuit, there is no energy stored in the capacitor. Now, since the total energy is constant, so at this point of time, we must have UL equal to Li max by 2, which is again equal to Q squared by 2C, because the total energy is constant. So this is, let's say, this is before, and this whole part is after. So we're just equating before with after. So from there, we can actually solve for the maximum current, I max, which is equal to square root of Q squared divided by L times C. So now if we use the given numbers, we have 6 times 10 to the power negative 6 coulomb squared. Oops. And we divide that by L times C, which is 60 times 10 to the power negative 3 Henry times the capacitance, which is 250 times 10 to the power negative 6 farad. And if we solve for it, we see that we have 0.001549 amp or 1.55 milliamp. Now for part C, the maximum energy stored in the capacitor is given by U max, which is equal to, again, Li max squared by 2, which is 60 times 10 to the power negative 3 Henry times I max, which is 1.55 times 10 to the power negative 3 amp squared divided by 2, which is 72.075 times 10 to the power negative 9 joule, which is roughly equal to 72.1 nanojoules. So we should get the same value if we actually have used Q squared by 2C instead of this, because the total energy in the circuit is constant. So we could have used this formula as well to find out the energy. Now for the final part, when I is equal to half of the maximum current, we have 1.55 times 10 to the power 3 amp by 2, which is 0.775 milliamp. Now the energy stored in the inductor again is given by Li squared by 2. So we can use the numbers, which is L is now 60 times 10 to the power negative 3 Henry. I is 0.775 times 10 to the power negative 3 amp, and we divide that by 2. So that gives us 18 nanojoules. So since the total energy is constant, so at this point we have UL plus UC, which should be equal to 72.1 nanojoules. And since we know that UL here is 18 nanojoules, so that means UC will be 72.1 nanojoules minus UL, which is 72.1 nanojoules minus 18 nanojoules, which is 54.1 nanojoules. Also, we know that this is equal to Q squared by 2C. So from this, we can actually solve for Q, which is basically 54.1 times 10 to the power negative 9 joule times twice C, which is C here is 250 times 10 to the power negative 6 farad. So we can use that number over here. And that will give us Q as 5.2 microcoulomb. All right, thanks for watching. I'll see you next.